Stanford University.
So first of all, thank you to Stanford and Apple for having me here. I'm really excited to talk about what I know about iPhone OpenGL. My name is Tim Omernick, and I direct creative R&D at NGMoco. And what I am responsible for at NGMoco is ensuring that my company is always on the cutting edge in terms of game technology and game design. And we are specifically focused on the iPhone. So if you've ever played Dropship or Mazefinger, I wrote those games. A couple other NGMoco games that maybe some of you are familiar with or have played, Topple, Wordfu. We just announced Star Defense, which is a 3D tower defense game that's coming out really soon. And then Rolando 2 is coming out this summer. So what are we going to talk about today? Well, we're going to talk about OpenGL on the iPhone at a few different levels. We're going to do a very basic application. And we're going to take a look at how we can improve that application in terms of its performance, both rendering and responding to multi-touch input. Those two are very related. And I'm also going to cover the sort of what I call the last 5%, which is the very, which are certain optimizations that you can perform for your iPhone application that'll just put it, it'll move it from good up to that great level. So why would you want to use OpenGL on the iPhone if you have, you already have UIKit, right? You can build these applications in Interface Builder and UIKit and Core Animation incredibly easily. You can do sliding transitions, flippy animations, fades, things like that. If you want to break out of that box and do anything custom, it's really, really good to drop down to OpenGL. It gives you much finer control over exactly what the hardware is doing to put those bits onto the screen. The iPhone system itself actually uses OpenGL to do all of its display. So all of those core animation effects you see for fading and transitions and such are actually implemented in OpenGL. If you want to write a game on the iPhone, if you want to write a good game on the iPhone, you should really think about using OpenGL graphics. You can really eke out the most possible performance out of the hardware and software that way. And this applies to 2D and 3D games. If you're just doing a simple, cartoony kind of sprite-based platformer game, OpenGL is still going to be really, really good for you to use in terms of getting that extra level of performance. Custom application effects, you can, if you're not writing a game, you can use OpenGL in your standard iPhone app to do, custom transitions between the different panes. OpenGL is also cross-platform, so there's a ton of resources out there online. I'm actually not going to show you how to use OpenGL per se in this presentation, simply because there are so many resources, so many books and tutorials and things online already to get you started with that. But there are some aspects of OpenGL that you should be aware of for the iPhone, so that's mostly what I'm going to focus on today. So what does the iPhone have in it? It has OpenGL ES 1.1. OpenGL ES is the standard for OpenGL graphics on mobile platforms. The 1.1 specification is fixed function, which means that you don't have vertex or pixel shaders, but you have all the rest of OpenGL. You can do all the kind of blending and texture coordinate effects that you might be doing in games. There's no immediate mode in OpenGL. So if you want to draw a scene that has lots of little objects everywhere, say there's a bunch of butterflies here and rocks down here, you can't just say draw a butterfly here and a butterfly here and a rock here and a rock here. You have to sort of batch your whole scene up into a big array and push that down to the graphics card. That sounds like sort of an unnatural way to program a game or an application, but it turns out that that's a good thing because it encourages you to be efficient in how you're submitting your geometry. I can show you more about that in a minute. So I thought I would just dive right in and do a little code demo, and we're going to write a little fireworks program. No, we're not. So the first thing I wanted to show you was just how to get started using OpenGL on the iPhone. Apple actually makes this really, really easy. If you go into Xcode, if you go into Xcode and go to New Project, there's a template that you can use right here called the OpenGL AS application. And if you choose this, we'll just call this test. if you make a project like this, it comes with something called EAGL view. And this is already configured to do the basic setup steps that you need to get OpenGL working on the iPhone. And basically, all this is a custom view class that has a special kind of layer backing it. This is a core animation layer that is that's connected to the OpenGL subsystem. So the way that you get started here is you can create one of these views that has this special layer. You can set drawable properties. You can set things like the color bit depth, as well as some other options on your context. And then once you have that, you can go ahead and just start drawing OpenGL content. It's actually pretty easy. In this example, in the template, they just have. Do you have a question? OpenGL is a library. It's actually it's an API, an application programming interface, and it's based on C. So any C family language you can use with OpenGL. In this case, this is actually an Objective-C application. It's just a regular UIKit-based app that's calling into OpenGL through C. Does that answer your question?
Okay. Yeah. So because Objective-C can run C code, and
yeah, because
OpenGL isn't C, then we can run.
Yeah, exactly. You can use any C library inside of Objective-C, which is actually really, really nice. I tend to, when I'm writing a game, I'll use Objective-C for all the high-level kind of structural parts of my application, because it's really nice to build out your class hierarchy in sort of a natural object-oriented way. But then when you really want control over exactly what's going on in terms of copying memory around and that kind of thing, and you want to use some of these lower-level APIs like OpenGL, then yeah, you can drop down to C and just go ahead and use that inside of your Cocoa app. So I realize there's a mix of OpenGL and C experience in here. So sorry if some of this seems a little too brief, or if some of it even seems a little bit too detailed. By the way, all the code that I'm showing you here, I'll be posting online later, so you'll be able to check it out and look into it in more detail. But this basic OpenGL example, all it does, let's just run it here. Just gives you a spinning square. It's kind of your canonical OpenGL demo. It's not incredibly interesting, but it should just show you that literally within 15 seconds you can get an OpenGL app up and running on the iPhone.
And that's based on a template?
This is based on a template, yeah. And again, that's built into Xcode. So this is actually a talk about OpenGL performance on the iPhone. This app actually runs really great on the iPhone because it's a little spinning square. It doesn't really do a whole lot. So I'm just going to go ahead and close this and switch over to this fireworks demo that I put together. The wrong one. And what I've done here is I've replaced the drawing of that spinning square with something a little bit more interesting. I'll just go ahead and give this a run so you can see what it does. Oops. So this is actually slightly buggy. There seems to be an issue here. Let me just run this again. There, now it looks right. And you can drag your finger around and make little sparkly fireworks and stuff. This is actually really fun to play with in the dark. You should just turn out all the lights and check this out. It's pretty cool. Whoa. So it's pretty cool. One thing here is that this actually supports multi-touch. So I've got two fingers that are making fireworks here. You can swirl them around like that. And what I wanted to show you, and I'll show you why this is in just a minute, if you get going really fast, you just start scrubbing around, making lots of pretty fireworks. You see it starts to kind of chug. The performance gets a little slow, and they're not really following your fingers around like you'd want them to. It just doesn't feel like this immersive experience. And that's really what I was going for this fireworks app, was just some sort of you're just lost in the fireworks. Just you're almost controlling a fireworks show or something like that. It just doesn't quite feel like that yet. So, let's take a look at actually what I'm doing in this program to make this happen. It's really pretty simple. It's a particle system. So I've got a list of particles, and every particle in my app has a position, it has its size, it has an alpha level, so it can fade in and out. It has a color, so I'm doing sort of color cycling effects to give you that kind of on-fire look. And basically all I do is I go through each particle here, and for every particle I make a square. So here I've got my vertices array just has my x and y positions for the corners of my square of my particle. And then I have a texture for that particle. I compute the color for it. And here's where I actually draw the particle. What I do is I move the I go ahead and move the matrix over to where the particle is, and then I rotate. So the particles are all kind of independently spinning. And then I go ahead and say, OK, OpenGL, draw this array, which is the square, the particle corners that I built up a little earlier. And I just do this for every single particle until I hit the end of the list. If you got started, writing an iPhone OpenGL program that did something like this, maybe this would be kind of your first attempt at getting something like this running. And this works. This is fine. As you saw, it made pretty fireworks and stuff, but it wasn't quite fast enough. So why? What exactly did I do wrong? I could guess about a lot of different things that would cause something like that in my program, but I'm not going to guess. Instead, I'm going to take a sample. There's a program included with the iPhone SDK called Instruments that you can use to get a profile of your running application. If you run this application under Instruments, you'll see it's actually pretty optimized. There isn't a lot of time spent in the program moving these particles around or fading them in and out or anything like that. What's really going on here, if you look at this profile, I'm spending almost all the time in my program just drawing that array of particles. And I'm also spending some time doing that translate and the rotate. I'm spending some time binding to textures, things like that, things that are just calling into OpenGL. And for some reason, OpenGL is using all the time. So how can I actually make that better? Before I go any further here, I just want to say a lot of what I'm going to cover here is already documented in various publications online. PowerVR and Apple both have fantastic documents that go over sort of the general programming guidelines. The PowerVR document in particular has a lot of very interesting tips and techniques that you can use to really get right down to the metal and to make sure that your app is running optimally. I highly recommend that you read this. You don't really need to copy down this link right now. All these slides will all be posted later, so you can go check things out. But I just kind of wanted to point you guys at those, because this talk is really just a distillation of the information you can find in all of these online resources. So the general optimization strategy that I wanted to talk about here for fireworks. There are really 5 things that can help make an iPhone application fast, an iPhone OpenGL application fast. The very, very biggest one that you can do is to batch your geometry. So you noticed in that in the code that I was showing you, I'm looping through each particle, and for every particle I build that array, and I say, hey, OpenGL, draw it. And then draw this one, and then draw this one, and then draw this one. That works, but that's really, really, really not what OpenGL wants to do. Another technique that we're going to look at is called texture atlasing. And this is a technique that you can use to take, if you have a lot of different objects on the screen that look different, you can actually make them sort of the same object by giving them little subregions of a single texture. And you can use this for animated sprites, you each have like a butterfly flapping its wings, or you have like different firework particles or something like that. You can actually combine different textures into one texture, and that'll actually get you a lot of speed. Interleaving arrays, the particular format, the order in which you specify both the arrays of vertices and the data about those vertices to iPhone OpenGL matters a lot. Because if you don't put it in exactly the right format, the driver is just going to totally convert whatever you gave it into whatever format it wants to consume. So if you can send everything down to the driver in the correct format, you can often skip a lot of work. I'm also going to talk about index triangles and floats versus shorts, which sometimes, just depending on the app you're writing, will get you a little speed boost, maybe not. I'll go over that. But the single biggest thing that you can do, I see this. Hey, you have a question? Yeah, all of the optimizations I'm talking about today are, in fact, valid optimizations on any implementation of OpenGL. This is stuff that applies to the Mac, to the PC, to consoles, to, I mean, anything. It's just that for the iPhone, there are a specific set of optimizations that tend to have the very highest payoff. And so that's what I'm going over here. Batching geometry. This is by far the biggest optimization. Every single game that I work on or help with, this ends up being the very first thing that I attempt doing. I'll let you answer that. The basic idea here, the basic strategy is to minimize your usage of OpenGL. So just try to batch up all of your geometry into very large arrays that you draw once. So if you have 100 objects on the screen, instead of drawing each one in turn, just put them all into a big array and do it with one draw call. The other thing here is by batching up your geometry into similar objects, similar textures, things like this, you can avoid changing state. So imagine you have 100 objects on the screen, and some of them are red and some of them are blue. And you want to draw all of these objects as fast as possible. The worst way that you could possibly do it is to just go and draw a red object and then a blue object and then a red object and a blue object. Because every single time you have to tell OpenGL what the color is and where this thing is and that it's blue. And then you have to go set the color again, set it back to red, draw the color. You know, it becomes this process. So if you can try to batch everything up, draw all your red objects and then draw all your blue objects, that'll be a lot more efficient. Texture atlasing, I was talking about this a second ago. The general idea is to, instead of using lots of different textures, try to make pages of textures that you can use for all of your objects. Interleaving arrays. Sometimes this will help you, sometimes this won't. It kind of depends on the application. This actually was a pretty big payoff in the Fireworks application. I can show you a little later. The basic idea here is when you're building these arrays of objects, instead of making an array of vertices, an array of texture coordinates, an array of colors, try to pack them all into one interleaved array. So you have vertex 1, color 1, texture coordinate 1, vertex 2, texture 2, and so on. This is the format that both the driver and the hardware expect, and it'll convert into this format anyway if you don't do this. And so if you can keep your data in your application in this format, it'll just run a lot faster. Indexing triangles. So this is another way that you could submit geometry to OpenGL. If you think about what an OpenGL program is doing, really all it's doing is submitting geometry to a graphics card. And it can do this by saying, OK, there's a point here, there's a point here, there's a point here, there's a point here. And you can just give it the list of points. And this works, but imagine if you had a scene that was built up of some complicated mesh where a lot of the triangles in your mesh actually share points. They have coincident points. What you can do is submit each unique point and then define the mesh as indexes into that so that you don't re-specify redundant vertices. So depending on the application, this doesn't really help me in Fireworks app that much. But depending on the application, this could actually be a really, really big memory-saving operation as well as a reduced CPU overhead. And you can, well, OK. Texture compression. The iPhone texture compression format is PBRTC. This is PBR texture compression. You can take images and compress them down into 4 or 2-bit images, which are vastly smaller than JPEGs or raw RGBA images. You can get a huge amount of memory savings here. But even more importantly, if you do texture compression, you can achieve higher throughput because you're sending much, much, much less data down to the card. So that's just a general overview of kind of the big ticket items in terms of iPhone OpenGL optimization. Let me just show you the Fireworks app with those optimizations applied. Whoops. I'm not used to using PowerPoint. I like Keynote better. So this is the optimized version of Fireworks. And we still go through every particle every time we draw. But the subtle shift here is in the way that we collect this geometry before sending it to OpenGL. Instead of doing it one particle at a time, we do it all at once. So you can see here, instead of going and rotating through OpenGL, telling it, OK, this particle has this rotation and this location, we just manually do the math to figure out where the sort of rotated corners of each rotated particle are. This allows us to avoid changing GL state, which is a pretty expensive operation. Here we've got a basic texture atlas. So I've got two particle sprites that I'm using for my fireworks. I've got one that's kind of this glowy thing with a ring around it, and one that looks a little bit more like a fireball. And we just sort of randomly alternate between those. And what I'm doing here is, based on the texture that the particle uses, I just switch the texture coordinates into that texture that are referenced. And in that way, I can avoid binding and rebinding to the same textures over and over and over as I'm drawing these particles. I basically bind once before I start drawing, and then I just start referencing into that bound texture. Here I'm calculating the color for the particle as well as its alpha value. And notice that I'm packing the color into a 32-bit value, which is, instead of using 4 floating point values for my RGB color, I'm just using a single 32-bit value, which is significantly more efficient. And this is really the key here. Instead of sending these vertices directly down to OpenGL, I've written this function called addVertex. And all this really does is it takes my x and y and color and texture coordinate, and it just appends them to an interleaved array. And at the very end of that, I go ahead and flush and submit it to OpenGL. So here's my addVertex function. It's pretty simple. I just grab a vertex out of a global array, and I add the data about it, and I increment my counter, so the next time around I'll add it to the end of the array. And then here's my flush function that I call at the very end of the process after I've drawn all my particle systems. And what this does is it tells OpenGL, OK, here's a really big, giant vertex, texture, and color array. Go ahead and draw it. And it just does that in one single step. So what does that actually do? So it looks pretty much the same when you're, you can see it's a little smoother when you're doing one at a time. The key here, though, is when you start getting into multi-touch, you start doing a lot of particles at the same time. It's really hard to slow this down. This is smooth as butter. So that's the optimized fireworks demo. Thank you. Again, the source code for, man, why does it do that? The source code for this will be up on gamemakers.ngmoco.com later on. Gamemakers.ngmoco.com is our company blog, and we talk about issues like this, iPhone game programming issues, as well as production and design kind of issues. It's a really interesting site if you're at all into gaming. I wanted to show you guys really quick. I had about 2 days notice to put this all together, and so I was thinking, okay, how can I show these guys how to do something kind of cool looking in OpenGL in the iPhone? And I thought, okay, I've written a ton of particle systems before. I'll just do one of those so I can just whip it together real fast. But I think you guys have probably seen like a lot of particle system kind of demos and stuff. It's usually kind of like the hello world of OpenGL applications. So I wanted to show you something a little more interesting. This is a game I'm working on right now called Livefire. This is still, I probably shouldn't even be showing you this. This is still like in the alpha stage of production. Oops. All right, so here's my dude. Actually, I'm just going to take you to a test map that we're working on right now. I just need to get this. You guys have to edit out the updating Evan fixing my computer part, all that kind of stuff. So you can actually pull off some pretty crazy complex stuff on the iPhone. we took the Quake 3 engine and we applied all of those optimizations that you heard about today, and we're able to get somewhere between 20 and 45 frames per second on the iPhone and iPod Touch. This is with 4 players in a multiplayer match over 3G on a bus. So I think it's a pretty cool thing, and it just goes to show the iPhone is actually a pretty powerful gaming machine.
What's your controls?
Oh, you want to know about the controls? I have have you guys ever played Dropship? Is anybody familiar with that game? Come on, throw me a bone, I wrote it. I understand. So basically the way this works is the left side of the screen is it's kind of like analog control sticks, just like on a Xbox or a PlayStation or something. The left side of the screen moves you around, so you can go forward and backward and around like that. The right side of the screen lets you look around. The right side of the screen is also how you fire. And if you've ever used like the iPhone or like specifically like scroll views on the iPhone have this, or like the Google Street Level view where you kind of like toss things around and stuff. It's sort of this inertial scrolling mechanism. So you just sort of like touch it and then toss it, and then you can shoot your rockets as you go. And then you can tap on the bottom to jump, and then tap on the top to get to a little menu. And we have lots of different interesting guns in here. This is it's like a futuristic weapons testing facility. So I just picked up a jetpack and I'm flying around now.
Is it using the accelerometer?
We don't use the accelerometer. We actually played around with an accelerometer-based control scheme for this. This is very off topic. I'm stuck in this little thing. Hang on. Very off topic, but I'm not a big fan of accelerometer games simply because they're kind of hard to control. They feel they all reduce into sort of a balance ball game or something like that. They feel fragile, if that makes any sense. Here's a grappling hook, which lets you kind of grab onto walls. This is actually a really fun way to kind of move around. You can hang up here on the ceiling and like wait for dudes to go by and then drop down on them and kick them in the head. So anyway, yeah, that's live fire. You can actually do some pretty cool things with OpenGL on the iPhone if you use these techniques.
Could you shoot some more stuff?
Sure, you want to see some more guns? We have we're still working on all of our guns. I have this is called a mass cannon. It's like a laser shotgun. Let's see. Oh, I really like this gun a lot. This is probably my favorite one, the antimatter jet. And this gun is sort of like it's a weightless grenade. It bounces off of walls. So you can use this for like area denial. You can just shoot it like over here and just kind of set up these like floating mines. So if people run into them, I'm just gonna go like run into one here. Ugh. It kind of kicks you back, takes away about half your life or something. It's kind of a fun way to use. You can like fill up these little rooms here.
Could you talk a little bit about device versus simulator performance?
Oh yeah, that's actually a good call. Obviously, the fireworks demo I showed you and this game and everything, these are all running in the simulator. When you're writing an iPhone application, don't use the simulator to gauge performance because it's nothing at all like the hardware. The iPhone simulator is a software implementation of OpenGL. It's just running on your Mac. Macs these days are really, really fast and beefy, so obviously it's going to be able to just take whatever you can throw at it. So whenever you're writing anything where you need to know the level of performance, test it on an iPhone, profile it on an iPhone, and check your fixes on an iPhone, because that's the only way you're going to know what you're actually shipping to people.
When you're testing on a device like this, matter too much? I mean, how much variation is there from device to device?
From device to device, there isn't a huge difference. The iPod Touch is significantly faster than the iPhone 3G. So just be aware of that. I tend to do development on a first-gen iPhone, just so I kind of know, the kind of lowest level of performance I'm going to get. That said, I mean, it's not a slow device at all. If you optimize using these techniques, you can actually get pretty good performance on the first-gen iPhone. But as far as device to simulator, it's apples to oranges. You can't even compare. This took a lot of work for me to port. If you can get the Quake 3 engine open source from id, and a few people have actually already ported it to the iPhone. You can find demos on YouTube and stuff. The thing is, I gutted most of the rendering backend inside of the Quake engine. The renderer itself was structured exactly how I wanted to render on the iPhone, because it does all of this stuff that I was talking about minimizing state changes. It does this by sorting objects that are all alike and drawing them kind of in batches, which, that's like the #1 thing you need to do on the iPhone. So I chose it specifically because it had that aspect. But then I went in and I changed everything around, so it's sending everything down in compressed interleaved verts, it's using PBR texture compression, it's doing everything completely iPhone optimally. So you could actually do that. You could start with a Quake engine and port it. It might be a lot of work though.
I'm wondering if you could limit the memory you give to the simulator
Limit the memory you give to the simulator.
to like actually simulate.
Right. The way that I do that is I have a texture manager that knows how much memory it's using, and I just impose a limit inside that class inside my application. And I mean, there's nothing built into the simulator to do that. It'll just kind of allocate whatever memory you want to allocate. But you should, if you're writing an iPhone application anyway, and you're loading a lot of textures, and you're hitting up at that, like, you shouldn't load any more than about 24 megabytes of textures at any time. And if you're running up against that, which I am in this game, you really should have something in your application to manage that and make sure that you're not trying to load more than you possibly can. And you can use that on either the simulator or the iPhone if you have that. You should talk to Id about that. Yeah.
Sorry, could you repeat the question?
Oh, repeat the question. He was asking the license details on the Quake engine. That's really something that Id works out with different companies. But generally, if you want to make something commercial, you have to buy it. Fill rate is not usually an issue. It's almost always, sorry, the question was, have I ever been bound by fill rate or geometry? And the answer is yes, but specifically geometry. Sending down triangles and vertex attributes to OpenGL, just submitting your geometry, tends to be the single biggest bottleneck. So minimizing the call count and compressing down all that data into the smallest possible format is really how you kind of manage that. There is actually support for VBOs, and I didn't talk about that today because it turns out on the current generation hardware and driver, VBOs don't actually give you a performance gain. But I like to use VBOs anyway because, yeah, I mean, maybe someday they'll like turn it on or something and it'll actually, make it faster. I don't know.
What are VBOs?
Oh, VBOs are vertex buffer objects, and this is a way that you can more finely control the way that you allocate vertex and attribute memory and feed it into the OpenGL driver. So you can do things like avoid copying from your application through the driver onto the card, skip a memory copy. For example, if you have a mesh that never changes, you can make a VBO out of it and just give it to the driver and say, here you go, here's my mesh. I'm never going to touch it again, so don't worry about it. Just go ahead and just keep it resident on the card. So you can do things like that. But right now, the level of support on the iPhone isn't quite there. So, oh, okay. He's asking, is there an opportunity to use an iPhone as like a input device, like a gamepad or something like that?
More powerful.
That's actually a really cool idea. You should write an app that does that. He's getting out of here right now to do it. Yeah, I mean, you could definitely do something like that. In general, I see the iPhone as not a mobile device for gaming, but I see it as something that is a lot closer to a computer as far as the way that you develop on it. If you can just use Xcode and GDB and instruments and all these tools you use to write Mac applications, the turnaround time for developing on an iPhone is just amazing. And the power of the hardware and software itself, as you just saw with Livefire, you can do some pretty cool things with it. So it's a really, for me, it's a first-class gaming machine. Our entire company is based around iPhone games because we believe in it as a gaming platform. Do we look at battery life? Yeah.
How do you optimize for that?
It's really tricky to optimize for battery life because in games you really want to make things look as good as possible, and so you're using as much of the hardware as possible. That's like the exact opposite thing you're supposed to do if you want to conserve battery life. There are things you can do there. One thing that I do is I make sure that I'm not. Most games are set up to just draw frames as fast as they can. They just have a timer that's like 30 frames per second, just draw. Sometimes you don't need to do that. Like if you're stuck on a menu screen and the screen is fixed, you can actually just stop drawing at that point and only draw when there are changes to the screen. You can just write more efficient code. I mean, it's always good to profile your code and just see if there's things that you can make faster. And by doing that, you know, you're going to be using less resources, and therefore you're going to be draining the battery a little less. Another big thing is using the cell network or Wi-Fi. So just be really careful if you have something like a multiplayer game to not try to like continuously, depending on your access patterns, it might be better for you to keep a connection alive the entire application. It might be better for you to like open a connection to a server and download something and then close it, because you're only doing that once in a while. So, you know, it's good to just kind of keep an eye on that and try different things. You had another question?
When are you going to release it?
This summer. I can't wait. Do we have a question in the back there? Yeah, for Livefire, I'm targeting OS 3.0 because I'm taking advantage of some of the newer push notifications. You'll be able to invite friends over push notifications, as well as buy things inside the game. He was asking if 3.0 is faster in GL. I don't know, no comment there. Any other questions?
Do you guys need interns?
We are looking for interns in Njimoco. If you guys, you know, are looking for a job this summer or something, my email address is tim@njimoco.com. So if you have any questions about the presentation or you want to get in touch about, you know, pretty much anything, go ahead and shoot me an email. Yeah, I'm going to hang out for a while. If you guys want to come chat about stuff, I'm open to that. You can also email me, tim@njimoco.
Thanks, Tim.
For more, please visit us at stanford.edu.